All right, we are taking a look at section 14.5, and it's another application of double integrals. We're going to take a look at surface area. So we've got some sort of solid, and we're looking to find the surface area of that solid. So it says if f and its first partial derivatives are continuous on a closed bounded region R of the xy plane, then the area of the surface S, which is given by z equals f of xy over R is, we're going to get a formula for surface area. We're going to integrate over that region R. So we're going to do the double integral with respect to area. So we'll have a dA. And on the inside, what we're going to have is this is going to feel fairly similar to our prior things when we looked at surface areas, or they also are kind of similar to arc lengths, where we're going to have a square root. And on the inside for this particular one, we're going to have 1 plus, we're going to take the first partial with respect to x, so f sub x, and that's going to be a function of x and y, and we're going to square that. And then we're going to take plus the first partial with respect to y, so f sub y of xy, also squared. So we're going to basically add 1 with the squares of the two first partials. So you could also, if you want, instead write this as z sub x and z sub y. Just depends on preference, or you could put dz dx, or the partial of z with respect to x, or the partial of z with respect to y. But basically it's those two partial derivatives added together. So this idea of having the square root and the derivatives squared and added should feel somewhat analogous to prior surface area and arc length formulas, but this time we're doing that double integral with respect to area over the region R.